Here in section 9.2, we're going to look at outcomes of a hypothesis test and different types of errors that can occur. So this table represents, here's the outcome of the test. You can either fail to reject H0, in other words, you accept it, or you can reject H0, in which case you would accept HA. And then over here in these two columns are the truth state of the null hypothesis. So if you accept H0 and it's true, then that row and column intersect. That's a type A correct decision. Its probability is 1 minus alpha, where alpha is what we call the significance level of the test. And then if you accept H0 as being true, but it's really false, then you've made an error. That's called a type 2 error. It has probability beta. We won't be determining beta. And then if you reject H0 here, when it's really true, that's called a type 1 error. So we're interested in that type 1 error and that type 2 error. And alpha is the probability. So alpha is the probability of a type 1 error. And then if you reject H0 and it's false, then you've made a correct decision. We call that type B correct. So we're interested in these two. We want to kind of put those errors into words. So here's an analogy that works well to illustrate these errors. It's the judicial system. So in our judicial system, you are innocent until proven guilty, so the null hypothesis is that you're innocent. And then the alternative is that you're guilty if you're accused of a crime. So a type 1 error, when you reject H0 here, when it's really true, that means that you're going to conclude that the person is guilty when they're really innocent. And we don't want to do that. That's a serious error because the consequence is you're going to put an innocent person in jail. Type 2 error here is when we accept H0 when it's really false. So we're going to accept innocence when they're really guilty. So conclude a person's innocent when they're guilty. Consequence is you let a guilty person go free. We don't want to make that error either. However, just like hypothesis testing, our judicial system is imperfect. Sometimes there's not enough evidence to convict a guilty person, and sometimes the evidence looks like the innocent person is actually guilty. So let's look at an example here to illustrate. So we have our H0 is that the majority of U.S. residents do not support term limits for Congress. So then let's decide what our HA is, which is the opposite here. And that's going to be that they do support term limits. So if we make a type 1 error, so that's when you reject H0 when it's really true. So if that's the case, you're going to reject H0. You're going to conclude they do support HA when that's not the case. They do not support. So you're going to, here you're going to conclude that they do support term limits when they really don't. And then what's going to be the consequence of that error? So if you conclude that they do support term limits when they really don't, you're going to enact term limits that the people don't want. You're going to pass a law they don't want. That they really don't want. How about type 2 error? So type 2 is when we accept H0 as true, but it's really false. So we're going to accept as true that they do not support term limits when they really do. So here we would conclude that they do not support term limits when they really do. And then what would be a consequence of that? So if you conclude that they don't support term limits, then you're not going to pass term limits that are really wanted. So you don't pass term limits that are really wanted. So that's type 1 and type 2 error in that situation. Let's look at another example. Our null hypothesis here is that RA drugs do not increase cancer risk. So these drugs, there are a lot of side effects, and what they found is that actually the cancer risk is increased if you take some of these drugs, because they dampen the immune system too much, and the immune system is what fights off early cancer cells. So our alternative hypothesis here is going to be that they do increase risk. So then what's going to be a type 1 error? Well, type 1, remember, we reject H0 when it's really true. So if we reject H0, we're going to conclude HA. So we're going to conclude that they do increase risk when they really don't. And then what would be the consequence of that? So you're going to conclude that these drugs increase risk when they really don't, and cancer probably is more severe than autoimmune disease. So it could be the case that the FDA says, oh, this risk is too high, we're not going to approve this drug, depending on what the sample data say. So we could not approve a safe drug because we think it causes cancer, but it really doesn't. What would be a type 2 error? Well, type 2, remember, you accept H0 when it's really false. So we're going to conclude that they do not increase risk when they really do. And then what would be the consequence of that? Well, the sample data is showing us that they don't increase risk, so we're going to approve this drug, but then it's actually dangerous. So we could approve a dangerous drug. So again, we don't want to make that error. We don't want to make either one of those two types of errors. So we can't completely eliminate either type of error, but we can find a balance, depending on which one we think is more severe.